Assalamu alaikum to all of you. I'm very grateful to you all for taking the time to be here today. Let me start by telling you a little bit about my own background. Myself Marwa Bibi from BS Biochemistry Department, and today I'm here to present a topic which is 1,4-dihydroxyanthraquinone. What I intend to do is to introduce all of you about my topic 1,4-dihydroxyanthraquinone. It covers its basic concept. After having a look on its introduction, we will move on toward its structure, and after that we will continue its preparation method, how it is being prepared on a large scales. After having a look on all of these topics, we will talk about its applications in our daily life, and at the end we will summarize our presentations. What at the end of my presentation, what I hope you will get from my presentation is a clear view of this compound, its structure, its property, and mainly its importance in our life. I would like to begin by drawing your attention toward the topic 1,4-dihydroxyanthraquinone, which is basically a derivative of anthraquinone. Anthraquinone is basically an important component and a member of a quinone family. It is basically an aromatic organic compound. Aromatic compounds are those compounds which contain benzene ring. As far as quinone is concerned, it is actually a member of class of a cyclic organic compound which contain two carbonyl group. And how it is being derived from anthraquinone? It is derived from anthraquinone by the replacement of two hydrogen atoms by hydroxyl groups. And that's all I want to say about this topic from the time begin. Here is a nomenclature of or compound. The most frequently used name is quinine, and the second one is the solvent orange 86. Solvent orange 86 is so because of its appearance, which is usually red to orange powder. As far as its IUPAC name is concerned, the most preferred name is 1,4-dihydroxy anthracene 910 dione. Now let's turn on to the structure of 1,4-dihydroxyanthracene. If you remember, I touched upon the point earlier that anthraquinone is basically a quinone which contains two carbonyl group. And here you can see that a second ring of benzene contains two carbonyl group, and there are also two hydroxyl groups which are present on a carbon number 1 and carbon number 4, and due to their presence on a carbon number 1 and carbon number 4, it is known as 1,4-dihydroxyanthraquinone. Now let's have a look on its preparation method. There are basically three types of preparation method by which we can prepare a compound. The first one is by dissolving para-chloroaniline, condensing with phthalic anhydride and hydrolyzing, and the second one is by treating anthraquinone with ammonium sulfate and sulfuric acid, and third one by heating para-chlorophenol, phthalic anhydride and ether sulfuric acid and ammonium chloride. This led me directly to my next point, which include the steps of its preparation method. The first one is heating boric acid to prepare boric acid dehydration compound. And the second one is adding fumic sulfuric acid, phthalic anhydride, the boric acid dehydration compound, and para-chlorophenol into condensation catalyst in sequence, and carrying out condensation reaction at 100 to 250 degrees Celsius. The third step is adding a proper amount of water and the material in the condensation catalyst into a hydrolysis catalyst. carrying out hydrolysis reaction at 50 to 115 degrees Celsius, discharging a reactant, filtering the reactant by pressing, washing and drying the reactant to prepare 1,4-dihydroxy anthraquinone. According to the method, the boric acid dehydration compound is used as a catalytic, and catalytic is that one which increases the rate of reactions. So that addition of amount of raw material, including fuming sulfuric acid and phthalic anhydride, is reduced. The resource consumption can be reduced, as a result of which the cost is reduced, the waste emission is reduced. This method of preparation is relatively environmentally friendly and economical. Now let's turn on to the properties diagram, and here you can see that how a phthalic anhydride and para-chloroaniline are reacted together in the presence of the boric acid and sulfuric acid, and how the intermediate is produced which rearrange themselves, and dehydrations occur. As a result of all this process, we get aquazinarine, which is actually a 1,4-dihydroxyanthraquinone. Now let's move on toward our next slide, which is about the properties. The properties may differ very much. It mainly includes chemical formula, which is round about 614 8 H10O4, and the molecular weight, the melting point and boiling point, in its appearance, which is usually in a form of powder and orange to red brown crystalline powders, and then its density and a vapor pressure. Now, as far as solubility is concerned, 1,4-dihydroxyanthraquinone is not soluble in water but soluble in other organic compounds such as alcohol, ether, aqueous alkalis, and ammonia, but with the variations in their color. When they are soluble in alcohol, they show a red color, while in ether they have a brown color, while in a case of aqueous alkalis and ammonium, they are soluble with a violet color. Here is a reaction between a leucocyanidine and quinidine, and you can see how the hydroxyl group of the quinidine is being replaced by the ammonium group in the presence of air. At the last, we will discuss all the application of anthraquinone. Anthraquinone has a wide range of applications, mostly in our daily life. Besides this utilization and colorant, anthraquinone derivatives have been used since centuries for medical applications, for example, as laxative and antimicrobial and inflammatory agents, and that's why how it formed the building block of many medical drugs. It is also important in a fungicide and pesticides chemicals, and because current therapeutic indications include constipation, arthritis, multiple sclerosis, and cancer. They inhibit the tumor cells growth. That's how they treat the cancer patients. Most of them possesses antibacterial, antiparasitic, fungicidal, and antiviral properties. They are also used as anti-cancerous agents. Anthraquinone are active component of many plant blends, which are used as a medicine and exhibit laxative, diuretic, estrogenic, and immunomodulatory effects. So let's move on to our next slide, which are also about its applications. As I told you earlier, it has a vast range of its application. It is used as to color gasoline and other heating oils. It is used to form lac pigment with calcium and barium in synthesis of lubricants and days, etc. So that brings me to the end of my presentation. We looked all the points, which include the introduction of 1,4-dihydroxyanthraquinone, what is basically it is actually a quinonine, a kind of a quinonine and derivative of anthraquinone, which is produced by the replacement and of hydrogen and by the hydroxyl groups. And after that we will discuss its preparation method and how it is being prepared, how the phthalic anhydride and chlorophenol react together, and how a glycerine is produced. And after that we discuss its properties, and at the last we discuss its applications in our daily life, that how they have been formed a building block in a medical fields. And the end of my presentation, these are all of the references from where I have gathered my data. You can visit to this website to access to that materials. And that's all about my presentation. Thank you very much for your attentions. Thank you very much.